Hi friends, this is Naresh. In this class, I am going to explain about centroid of an I and T sections. How to locate the centroid of an I section and T section. First of all, you have to know the centroid of a rectangle. The center of gravity of a parallelogram or a rectangle is at a point where its diagonal meet each other. So therefore, the centroid of a rectangle lies at a distance of base by 2 and height by 2. So x bar is the distance of centroid from uh, y axis, and y bar equal d by 2 is at a distance of y bar equal d by 2 from x axis. Now coming to the problem, uh, the dimensions of a T section is given here. The question is locate the center of gravity CG of the given T section. Okay, T section contains top flange and bottom web. The dimensions of a web is 20 mm, 20 mm by 60 mm, whereas the dimensions of a top flange is 100 mm by 20 mm. First of all, the given section is split up into two small rectangles like this. One is a horizontal rectangle, other one is vertical rectangle. The dimensions of a top rectangle is 100 mm into 20 mm. Therefore, the area of a top rectangle is 100 by 20. Now, the dimensions of a bottom rectangle is 60 mm height and 20 mm base. Therefore, the area of a bottom rectangle is 20 by 60. Now I am taking the reference axis to locate the centroid of a T section. Here, I am taking bottom rectangle as section 1, top rectangle as section 2. The dimensions of a bottom rectangle B1 and D1. B refers base, D refers depth or height. So therefore, B1 equal to 20 mm, D1 equal to 60 mm for section 1, that is web, and for top flange B2 equal to 100 mm and D2 equal to 20 mm. Therefore, the areas are A1 equal to B1 into D1 equal to 100 by 20 equal to 2000 mm square. A2 equal to B2 by D2 equal to 20 by 60 equal to 1200 mm square. Now I am drawing the reference axis. Here I am taking x axis at the bottom edge, and the given T section is symmetric about y axis, symmetric about vertical axis. Therefore, now I am taking the vertical axis at middle part. It is symmetric about y axis. The given plane figure is symmetric about y axis. Hence, the centroid lies on symmetric y axis only. So, the centroid lies on y axis only. Hence, the values of x1 and x2 are 0. Therefore, now I am drawing the diagonals to locate the individual centroids. C1 refers the centroid of a bottom rectangle and C2 refers the centroid of a top rectangle. C1, the centroid C1 lies at a distance of y1. y1 equal to height, half of the height, that is d1 by 2, whereas c2 lies at a distance of d1 plus d2 by 2, height of a bottom rectangle plus half of the top rectangle. So therefore here x1 equal to 0, x2 equal to 0, because of it is symmetric about y-axis. All these values are written in tabular form in next slide. Section number, plane type, dimensions, area, x values and y values. T section is symmetric about y-axis, hence therefore the values of x1 x2 equal to 0. There is no need to find the values of x. Now by using standard expression for a centroid, where xc equal to the distance of centroid or center of gravity from y axis, and yc is the distance or distance of center of gravity or centroid from xx axis, xc equal to a1 x1 plus a2 x2 by a1 plus a2. By substituting the values, you can get the answer x equal to 0. Similar way, yc equal to a1 y1 plus a2 y2 by a1 plus a2. We can get the answer. Here answer is yc equal to 35 mm. The final position of the centroid is I am showing the final position of a centroid or center of gravity. Okay, C1 and C2 are the individual centroids for bottom rectangle and top rectangle, whereas CZ is the centroid of a entire T section. The location of CZ is at a distance of YC equal to 35 mm and XC equal to 0. XC equal to 0 means lies on Y axis. This is the final answer for T section. In similar way, I want to solve the inverted T section. The dimensions are given here. The question is same. Locate the center of gravity of the given T section. And first of all, the given section is split up into two small rectangles, that is a horizontal and vertical rectangle. The dimensions of a bottom rectangle are b1 equal to 100 mm and d1 equal to 20 mm, and the dimensions of vertical rectangle are b2 equal to 20 and height d2 equal to 60 mm. Okay, now similar way, now I am taking the reference axis, x-axis at the bottom edge, and it is also symmetric about y-axis, hence y-axis. Now I am taking the y-axis at the mid part. Now I am drawing the diagonals to locate the individual centroids. C1 is the centroid of a bottom rectangle, and at a distance of y1 equal to d1 by 2. Similar way, I am drawing the diagonals for a second rectangle to locate the centroid C2. C2 is the centroid of a top rectangle, and at a distance of y2 equal to d1 plus d2 by 2. Here the bottom area of a bottom rectangle a1 equal to b1 into d1. So a1 is the area of a yellow rectangle and a2 is the area of a blue rectangle. So A1 equal to B1 D1 equal to 100 by 20 equal to 2000 mm square. A2 equal to B2 D2 B2 into D2 equal to 20 by 60 equal to 1200 mm square. From figure, x1 equal to 0 because of x1 x2 equal to 0 because of the given T section is symmetric about y axis. Y1 equal to D1 by 2 and Y2 equal to D1 plus D2 by 2, x2 equal to 0. All these values are written in tabular form in next slide. Similarly, xc is the distance of centroid center of gravity from y axis. Yc is the distance of center of gravity or centroid from x-axis axis. By using general formula, x equal to a1 x1 plus a2 x2 by a1 plus a2. By substituting the values, we can get the answer x equal to 0. Similar way, yc equal to a1 y1 plus a2 y2 by a1 plus a2. The answer is yc equal to 25 mm. This is the final answer, x equal to 0 and yc equal to 25 mm. Now I am drawing the final position of a centroid. Now here I am showing the position of a CZ. C1 and C2 are the individual centroids, whereas CZ is the centroid of a entire T section at a distance of yc equal to 25 mm. X equal to 0 because the given section is symmetric about y axis. This problem is very useful to find the centroid of a I section because both are in similar way. The question is locate the centroid or center of gravity of the given I section. The dimensions are given here. Bottom flange, web and top flange. The bottom base 100 mm and total height 90 mm. First of all, the given I section is split up into 3 rectangles. That is bottom horizontal rectangle, it is bottom flange. The dimensions of a bottom flange are B1 equal to 100 mm and D1 equal to 20 mm. Now vertical rectangle or web, the dimensions of a web are D2 equal to 60 mm and B2 equal to 20 mm. Now the top flange, coming to the top flange are a horizontal rectangle. The dimensions are D3 equal to 10 mm and B3 equal to 120 mm. Okay. Now I am drawing the reference axis. I am taking the x-axis at the bottom edge, and given I section is symmetric about vertical axis. Hence, I am taking the y-axis at mid part. The given I section is symmetric about y-axis. Hence, the values of x1, x2, x3 are 0 because symmetric condition. So there is no need to find the values of x. You have to find the values of y only. Now I am drawing the diagonals to locate the centroid, individual centroids. Now C1 is the centroid of a bottom flange at a distance of y1. y1 equal to d1 by 2, and C2 is the centroid of a web at a distance of y2, y2 equal to d1 plus d2 by 2. Now C3 is the centroid of a top flange at a distance of y3 equal to d1 plus d2 plus d3 by 2. Now coming to the areas, the area of a bottom flange a1 equal to b1 into d1 equal to 100 by 20. Therefore a1 equal to 2000 mm square, and a2 is the area of a middle section, that is web, a2 equal to b2 by d2 equal to 20 by 60 equal to 12,000 mm square, and area of a top flange a3 equal to b3 into d3 base into depth equal to 120 by 10 equal to 1200 mm square. So the given plane figure is symmetric about y-axis, hence the centroid lies on symmetric y-axis only. The values of x1, x2, x3 are 0. So y1 equal to d1 by 2, y2 equal to d1 plus d2 by 2, y3 equal to d1 plus d2 plus d3 by 2. These are the final answers. All these values are written in tabular form to find the values of xc and yc. So by using general expression, xc equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3. Therefore xc equal to 0 because of symmetry about y-axis, and yc equal to a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. Yc equal to, by substituting the values we can get the value yc. The answer of yc is 41.36 mm. Now I am showing the final position of a center of gravity of an I section. Where C1 is the centroid of a bottom rectangle, C2 is the centroid of a web, and C3 is the centroid of a top flange. Now CG is the centroid of an entire I section at a distance of yc equal to 41.3 mm. Therefore the entire for entire I section, the values of centroid xc yc, xc equal to 0, yc equal to 41.3 mm. It is the final answer and the final position of a centroid or center of gravity for I section. Thank you.